Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ala Zafira binti Azman and I am from J4EM1104B. My student ID is 2019428316. Today I would like to talk about hydrostatic force on plane surface. The objective of this experiment is to determine experimentally the magnitude of the force of pressure, hydrostatic force and its point of action center of pressure on both submerged, partially submerged plane surfaces. Second objective is to compare and analyze the experimental results with the theoretical values. And the third objective is students will learn about the fundamental physics of hydrostatic pressure, buoyancy, the center of pressure, flotation and the stability of floating bodies. The apparatus of this experiment is we will use hydrostatic pressure apparatus, and the first component is counterweight, second is tank, third drain valve, fourth adjustable feet, fifth balance arm, sixth quadrant, 7 balance pointer, 8 balance span, 9 weight, 10 depth of immersion scale, and lastly spirit level. The procedures of this experiment are: step 1 and 2, place the hydrostatic pressure apparatus on top of the bench and make sure that the apparatus is installed properly. Step 3, level the apparatus using the adjustable feet facilitated by the spirit level attached. Step 4, adjust the counterweight to level the balance arm to a horizontal position. Step 5, make sure that the drain valve V16 is closed and slowly add water into the tank until the surface just touches the quadrant base, thus establishing a datum level corresponding to 0 at the level scale. Please be careful when handling the measuring cylinder because it is very slippery. Step 6. Place a 50-gram weight on the balance span and slowly add water into the tank until the balance arm is again horizontal. Please be careful when handling the measuring cylinder because it is very slippery. Step 7. Record the mass of weight and depth of immersion in the experimental data sheet. Make sure your eye level is parallel with the depth of immersion scale to avoid parallax error. Step 8. Repeat step 6 and 7 with an increasing number of weights until the tank is full of water. Step 9. Drain off the water after the experiment is completed by opening valve V16. Please drain the water using the valve V16 to avoid any damage to the apparatus. First question, compare the experimental and theoretical values obtained and comment. As we can see, the values of second moment theory lower than the experimental values. This obtained result may be due to an error that occurred during the experiment. Next, when water is added, explain why the weight should need to be added as well until the unit is balanced. To answer this question, we will have to take a look on what hydrostatic pressure is. Hydrostatic pressure is the pressure that is exerted by a fluid at equilibrium at a given point with the fluid due to the force of gravity. Hydrostatic pressure increases in proportion to depth measured from the surface because of the increasing weight of fluid exerting downward force from above. If a fluid is within a container, then the depth of an object placed in that fluid can be measured. The deeper the object is placed in the fluid, the more pressure it experiences. This is because the weight of the fluid is above it. The denser the fluid above it, the more pressure is exerted on the object that is submerged due to the weight of the fluid. So, hydrostatic pressure systems allow for the measurement and development of hydrostatic force and the center of pressure equations and values necessary to build and evaluate fluid systems. To demonstrate this capability, known masses were added to one end of hydrostatic pressure apparatus and water was added into the system until the arm was level, balancing the moment of the pivot. Next, explain why the center of pressure is not at the center of the body. The velocity of a fluid varies over the surface of an item as it travels through it. The thin red lines in the illustration, the aerodynamic force on the object is calculated by multiplying the pressure by the surface area of the body. We can think of this single force as acting through the average location of the pressure on the object's surface. The average location of the pressure variation is referred to as the center of pressure, much as the average location of an object's weight is referred to as the center of gravity. Next, explain what types of errors are identified during the experiment and explain how it affects the experimental result. Transcriptional error happens when data is inaccurately recorded or written down. In this experiment, examples include when the values of resultant hydrostatic force or second moment are calculated is copied erroneously, or when a number is skipped when entering data from calculator into the datasheet. So, the pressure applied to walls of the dam will be a function of the amount of water that is over the point of the wall. So, water pressure is very large at the bottom due to its large depth. That's why dams are constructed thicker at their bottom than at their tops. As you can see from the diagram that the dam is much thicker at the bottom than it is at the top. This is because the pressure of the water is much greater deeper down and the dam needs to be thick at the bottom so that it is strong enough to withstand this large pressure. So, the conclusion of this experiment is the objectives of these experiments are achieved. The first objective is to determine experimentally the magnitude of the force of pressure and its point of action on both submerged, partially submerged plane surfaces. The second objective is to compare and analyze the experimental results with the theoretical values. Next, the resultant force created by a liquid's pressure loading acting on submerged surfaces is known as hydrostatic forces. The calculation of hydrostatic force and the location of the pressure center are essential concepts in fluid mechanics. The pressure center is a place on the immersed surface where the resultant hydrostatic pressure force operates. The magnitude and location of the water pressure force operating on water control structures such as dams, levels, and gates are critical to the structural design. Many aspects of hydraulic equipment require the design of hydrostatic force and its course of action. The formula of partially and fully submerged of resultant hydrostatic force and second moment are different. As for resultant hydrostatic force, the formula of partially submerged is F equals to rho G times B D square over 2. And for for the fully submerged is F equals to rho G AH equals to rho G BD in bracket D minus D over 2. As for second moment experimental, the formula of partially and fully submerged are, so for partial, H prime equals to mgl over F, which is equal to 2 ml over rho BD square. So fully submerged, for fully submerged, the equation is H prime equals to ml over rho BD in bracket D minus D over 2. To find second moment theoretical, partially submerged, H prime equals to H minus D over 3. So for fully submerged, H prime equals to, in bracket, D minus D over 2 square plus D square over 12 over D minus D over 2 plus H minus D. And there is a small difference between second moment experimental and theoretical values due to error that might be happening during the experimental execution. Error that could happen is transcriptional error, and it is happen when data is inaccurately recorded or written down. In this experiment, examples include when the values of resultant hydrostatic force or second moment are calculated is copied erroneously, or when a number is skipped when entering data from calculator into the data sheet. To summarize, further research is required to study a wider range of fluids. A design such as hydrostatic pressure apparatus with a hydraulic bench must be created. The same experimental procedure should be followed, and the same parameter influence on the apparatus such as correlations between the discharge and the time for the partially and totally submerged planes should be investigated. It is critical to investigate several apparatus parameters such as the center of pressure, depth of immersion, theoretical and experimental hydrostatic pressure. And I think that is all from me. Thank you.